Normally, we see just one or two bright comets grace our skies each year, a rare and fleeting spectacle. But this year, something unprecedented is unfolding. 7 massive comets will invade the inner solar system within just 6 months, including a visitor from another star. Since the dawn of modern astronomy, no one has recorded such an intense cosmic swarm so close to our Sun. And the clock is ticking. This extraordinary event will peak by the end of 2025. Could this celestial surge trigger powerful solar storms or even more dramatic cosmic effects? For those watching from Earth, some of these comets will be visible to the naked eye. What mysteries do these icy travelers hold? And what could their sudden arrival mean for our solar neighborhood? Stay with us to uncover the answers. In a typical year, the night sky offers the spectacle of 1 or 2 bright comets, sometimes 3 if we're lucky. These icy wanderers have fascinated humanity for centuries, but their appearances tend to be few and far between. Since the era of modern sky surveys, advanced telescopes like Pan-STARRS, Linear, and Atlas, astronomers have meticulously recorded comet activity. Yet, never before in the digital age have we seen 7 distinct comets crossing the inner solar system in such a short span. This phenomenon harks back to a time when astronomers relied on photographic plates, a slower and less precise method of observation. Even those historical records do not reveal a season overwhelmed with so many bright, active comets. This extraordinary cluster challenges everything we thought we knew about comet frequency and behavior. Could it be a celestial anomaly or the sign of an unseen cosmic trigger? Either way, it sets the stage for an unprecedented chapter in our observation of the solar system. What truly sets this event apart is not just the sheer number of comets, but the pattern and origins that define this cosmic swarm. These are not a slow, steady drizzle of icy bodies trickling through space. Instead, they arrive in a concentrated wave, a packed sequence of celestial visitors that offers scientists a unique chance to study their interactions closely. Among them, some are familiar periodic comets, making relatively routine orbits around the Sun. But then, there's the real outlier, the interstellar comet known as 3I Atlas. This visitor is traveling on a hyperbolic trajectory, meaning it's just passing through once and will never return. It's a rare glimpse into materials and conditions from a completely different star system. Each comet carries its own story hidden within its icy core and dusty coma. Their variety, both in composition and orbital paths, creates an unprecedented cosmic phenomenon. Imagine a swarm, not a scattered handful, but an ensemble moving through our solar neighborhood in close proximity, with the Sun at the center of this dynamic ballet. Scientists now see this as more than a list of comets. It's a living, evolving astronomical event. A grand spectacle that challenges what we understand about comet origins and solar interactions. The questions it raises reach far beyond the skies we see. Are these comets connected by a common origin? Could their clustered approach reveal new insights into the gravitational forces at play? As the months unfold, the behavior of this collective swarm will be monitored closely, promising revelations and perhaps surprises that only nature can deliver. Let's take a closer look at the key players in this cosmic swarm, the 7 comets and their journey through the inner solar system in 2025. Each comes with its own timeline, trajectory, and unique features that make this event unforgettable. Our first actor is Pan-STARRS, officially known as C2022N2. It reached perihelion on July 31st. Though distant and faint, Pan-STARRS marked the opening note of this celestial symphony. Its subtle presence signaled the soon-to-follow surge of cometary activity. a quiet herald of the remarkable events ahead. Next, we have SWAN, or C2025R2, discovered as recently as September 11th. This comet will make a close approach to Earth on October 21st, passing just about 0.25 astronomical units away. For those early risers and dedicated sky watchers, SWAN presents a rare chance to witness a comet so near before dawn, a delicate visitor glowing faintly against the darkening sky. Then there's Stereo, designated 414P, set to reach perihelion on September 27th. Unlike the others, Stereo is best observed not from Earth's surface but by the spacecraft designed to study the Sun's environment. Its proximity to the Sun makes it challenging to spot with ground-based telescopes, but it offers valuable data about solar-comet interactions. Atlas, or C2025K1, will come closest to the Sun on October 8th, passing even nearer than Mercury. Its fiery approach ignites intense activity, sending streams of gas and dust into space, creating spectacular tails that could be visible to specialized instruments. The spotlight then shifts to the interstellar traveler, 3I Atlas. This comet reaches solar conjunction on October 21st, with perihelion following on October 29th. It's unique not only due to its trajectory, but also its origin outside our solar system. Unlike the periodic comets, 3I Atlas will not return, making this a once-in-a-lifetime event. Its chemical makeup is unusual, with low water content and higher amounts of carbon dioxide and cyanide, and its coma spans more than 700,000 kilometers, larger than Jupiter itself. Following close behind is Lemon, designated C2025A6, anticipated to reach perihelion on November 8th. Lemon could be bright enough to see with the naked eye, shining around magnitude 4. The best viewing window lasts from November 6th to November 12th, particularly during evening twilight. A truly rare opportunity for amateur astronomers and casual observers alike. Finally, the sequence closes with 240 PNE, a periodic comet whose perihelion falls on December 19th. Although more subdued and dimmer compared to its counterparts, 240 PNE marks the conclusion of this unprecedented comet swarm. Each comet's journey weaves into a larger story, one of dynamic passages, changing brightness, and evolving visibility. Together, they create a cosmic event of exceptional scale and scientific importance, offering an invaluable natural laboratory to study comet behavior, solar influence, and the mysteries still hidden within these icy visitors. Comets are composed mainly of ice, dust, and frozen gases, remnants from the formation of the solar system. As they journey closer to the Sun, the heat causes their volatile materials to sublimate, creating a glowing coma or atmosphere, and the striking tails we associate with these celestial travelers. Interestingly, comets develop two distinct tails. One is the dust tail, made up of tiny particles pushed away by sunlight, bright and curved. The other is the ion tail, composed of charged particles shaped by the Sun's magnetic field and solar wind, often streaming straight away from the Sun. This ion tail is especially sensitive to space weather. Solar storms, such as coronal mass ejections, can cause a phenomenon called magnetic reconnection, where the magnetic field lines break and reconnect. This can abruptly disconnect a comet's ion tail, making it visibly snap away as if torn by invisible forces. A famous example occurred in 2007 with comet Encke. During a powerful solar storm, Encke's ion tail was ripped off, revealing the delicate interplay between the Sun and these icy visitors. Imagine witnessing such a cosmic dance live this year, as the swarm of 7 comets encounter our star's furious magnetic environment. This dynamic interaction offers scientists a rare glimpse into solar activity and comet composition. Observing how these celestial bodies respond to solar storms not only deepens our understanding of the comets themselves, but also of the Sun's influence extending far beyond its visible surface. The cosmic relationship between comets and the Sun is far from settled. Scientists remain divided on whether these swirling icy bodies can actively influence solar activity or merely serve as passive markers within the Sun's powerful magnetic environment. One school of thought, including researchers at NASA's Community Coordinated Modeling Center, CCMC, argues that comets might disrupt the Sun's magnetic field as they dive close, potentially triggering solar storms. The idea is that as comets inject material into the Sun's magnetosphere, they could create instabilities, sparking flares or coronal mass ejections. On the other hand, missions such as the Solar Orbiter and Parker Solar Probe see comets as silent passengers, distinctly visible but not powerful enough to cause disruptions. According to this view, comets simply follow the solar wind's flow, their ion tails shaped by solar forces without causing interruptions. This debate has set the stage for the 2025 observations to be a live experiment. Scientists expect to collect critical data that may finally answer whether comets are cosmic influencers or just spectacular bystanders. What the data reveals could reshape our understanding of solar physics and the complex interplay between the Sun and its celestial visitors. Among the 7 comets, 3I Atlas stands out as the most mysterious and extraordinary. Unlike the others, this comet is interstellar, originating far beyond our solar system. Its hyperbolic trajectory ensures it will pass through once and never return, a true visitor from another star. What makes 3I Atlas especially fascinating is its unique composition. Scientists have observed that it contains very little water compared to typical comets, but far more carbon dioxide and traces of cyanide. This unusual chemical mix offers a rare glimpse into the building blocks of distant planetary systems. Its coma, the glowing envelope surrounding its nucleus, already spans more than 700,000 kilometers, larger than the diameter of Jupiter. This enormous size makes it a spectacular target for telescopes. Another intriguing possibility is that 3I Atlas may leave behind a trail of debris, crossing Earth's orbit in 2026, potentially creating a meteor shower unlike any we've seen before. This comet isn't just a visitor, it's a cosmic time capsule, carrying clues from a distant star system and reminding us how much we have yet to learn from the vast universe beyond our own. For those eager to witness this once-in-a-lifetime celestial show, timing is everything. On October 21st, the best opportunity to see Comet Swan will present itself just before dawn, a delicate glow against the early morning sky. Then, from November 6th to 12th, Comet Lemon offers an even rarer treat, visible to the naked eye during evening twilight, weather permitting. While some comets may be too faint or too close to the Sun for direct observation, spacecraft like SOHO provide continuous coronagraph views available online, allowing anyone to follow the cosmic dance from the comfort of home. So, ready your telescopes, cameras, or simply your eyes, and prepare to look upward as these celestial visitors grace our skies. Predicting comet brightness or behavior is a challenge that has baffled astronomers for centuries. Despite all our technology, these icy visitors still hold secrets we can't fully anticipate. As powerful new observatories like Vera Rubin come online, our ability to monitor such events will improve dramatically. But the cosmos will always keep some surprises hidden. The sky is preparing a unique show for us, a rare cosmic ballet that will unfold before our eyes. All we can do is watch closely and prepare for the unexpected. If this cosmic mystery sparked your curiosity, stay with us. What's coming next will push the boundaries of space exploration even further, into realms where the known meets the unknown. Are you ready to journey deeper into the hidden secrets of our universe? Click through to discover what awaits beyond.